The thing that I'm saying is probably more likely the cause of him getting the same result is that he's shooting the cars really fast. And you have to wonder, why are they going so fast? Why are you forcing them to go so fast?
So first the nail was over here, you can still see the hole. Now I've put the nail over here, so the rubber band is stretched less, so it will definitely go slower.
The front end tends to lift up. Now, you also have a gigantic card on the car, okay? It's like gigantic. It's not a little card. It's a gigantic card, big sail, okay? So we don't need.
The card is now shorter. It was originally about this size, now it's like this. First, this part the magician shall cast a spell on this experiment. And abracadabra! So we have 8 readings for Mass 1, 7 readings for Mass 2. For Mass 1 we have 257, 253, 248, 250, 250, 250, 255, 254. If we take the average we have 252.1. For Mass 2 we have 370, 370, 369, 370, 365, 366, 373. If we take the average we have 368.5. Now let's take this, the calculator, and divide the numbers. 3, 6, oh, clear this, 3, 6, 8.5 divided by 252.1 equals 1.46. It is interesting to notice that we have 248, 250, 250, 250. 4 times we have very consistent results. And over here, 370, 370, 369, 370, also very consistent. Now we could assume that these should be the perfect numbers and the other numbers are small deviations. So if you pick 250 for this one and 370, you will get a different number, slightly different. 370 divided by 250, you get 1.48, a little bit higher. These are the calculations for the momentums and the kinetic energy. So the width of the card is 2.5 centimeters, so we can calculate the velocities, 0.991 meters per second for the one mass, and for the two mass we have 0.678 meters per second. The momentum comes for mass 1, 0.314. For mass 2 we have 0.429. For kinetic energy we have 0.156, so the one mass came out with 0.156 joules, and the second mass came out with 0.145 joules. So it lost 0.011 joules, which is normal because which is logical because the two mass will have more friction than the one mass, obviously. So it will lose a bit of energy. Now for the momentum, yes, we have lost momentum. So mass 1 has lost 115 momentum, all right? So which is a huge number in comparison to the kinetic energy number. So now you will ask, how is it that we have lost so much momentum? Well, that's what we have to find out, okay? This will always tend to happen no matter how many times I'm going to do this experiment. These will never match perfectly. There will always be a bigger difference for the momentum than for the kinetic energy. That's always the case, I'm sorry. And I can see that I don't really know why this is the case. In an elastic collision, for example, I do know because there is a reflection part, and then we have to then we have a momentum coming in, momentum coming out, and we have a reflection momentum, and then we have to subtract them, and then we will have the initial momentum. But in this case, we only have two momentums, and so I don't know how. And so I also don't know how if momentum is supposed to be conserved or not, and in what way it can be conserved. So please enlighten me too. So yeah, I'm really sorry, but I really can't help it that this 1.4 number keeps popping up. It's always, until now, it's in between 1.31 and 1.48. That's the range until now. Now I can try to do different experiments with different release mechanisms. I'm going to order myself an electromagnet, but I'm not sure if this is going to dramatically change the outcomes. That it suddenly will rise to almost 2. Not very confident about that. So yeah. I've been taking into account most of your points, such as making the flag shorter, making it go slower velocities. I've been testing both of the photo gates. They work pretty well, but still, right, it comes out 1.46 or 1.48. A little bit more of a difference. My previous experiment was 1.31, so okay, yeah, we got a bigger difference. But it's still not nowhere near 2 times the velocity. So I'm sorry, but this is what happens. And you cannot say I'm cheating because I'm taking into account most of your points.